Hello and welcome back to my Kubernetes series. In the last video, we went through the Dovecot container and its related config maps. In this video, I want to focus on the synchronization that we need to set up in order to have a fully synchronized master-to-master relationship. We will start on the lsync GitHub. As mentioned in the description, the lsync daemon watches a folder for a few seconds, spawns up a process, usually rsync, to sync a folder to one or more than one machine. Lsync is quite flexible and should be used in a low-profile environment where the files and changes are not that hard to sync. Imagine if you use your email server and how large an email file usually is. We're talking about kilobytes, not megabytes. There is a potential to run into issues if an email is larger in size due to an attachment. I am willing to take that risk. I could further mitigate this issue by limiting the size of emails I'm accepting on my server. I will not do that, but what I'm doing is to limit the size of emails I am allowing my users to send. If you look back at my postfix video, you can see this limit is about 8 megabytes. The setup files of lsync are using the Lua language. If we navigate to the examples folder and take a quick look at the lrsync SSH advanced Lua, we can see how a Lua config file looks like. This structure is what we will be building upon startup of the container. We will walk through that setup a bit later. If you want to dig into the documentation of lsyncd a bit more, please feel free to visit the GitHub at github.com/lsyncd shown on your screen. We will now switch over to my container builder and take a look at the container. Now that we are in the VM, to build the containers, we go into the build file, which is the lsyncd vim lsyncd. As per usual, I start off with an Alpine image and update and upgrade the packages without downloading anything to the container. I then install the packages rsync and lsyncd bash openssh and openrc. Then in the next step, I replace the out-commented identity file and remove the hash in the ssh config under etc ssh config. That step is important as I need SSH to work. I also activate port 22 and allow ciphers. Next, I add the SSH daemon to the RC update. I set up the soft level to output everything to dev null as I don't want to see errors or outputs. Next, I start the SSH daemon. Once done, I copy the entry point, ownership, and exchange key sh into the container. I change them to be executable. We will go through those files in a bit. Next, I set up a group which is called vmail. We use that group in postfix and Dovecot already, but as I want to sync emails as that user, I need to create that identity as well as its group first. At this point, I must mention that I was not able to get that sync as vmail user to work during my tests. I will try, but there is the potential the sync with that user will not work. We will get to that point later and see if it does. If not, I have a workaround in place just in case. Next, we set the entry point and commit to the container. That is already it, and we can exit this container build file. As you can see, there are 3 other files. Let's start with the entry point, vim entrypoint.sh, which kicks off the repetitive lsync execution. First thing, I call the exchange key. This function makes sure that I exchange the unique container ID keys with all other pods that need to stay in sync. Next, I request the RC status, followed by restarting the SSH daemon. Then I call the file ownership, as it will change the ownership of emails to the vmail user on all containers to ensure access to emails. Lastly, I start the lsyncd service, which, if everything goes well, I start with a vmail user. Okay, let's exit the entry point with write and quit and review the exchange.sh, the keyexchange.sh. Key exchange key. This file makes sure that at the startup of the container I'm exchanging keys through a shared storage. These keys are required to use SSH without a login and sync the data between the pods. The issue I have is that once the keys are exchanged, this script ends. I still have to come up with a way to exchange keys on an ongoing basis to ensure if a pod fails, for example, during an update of the cluster where you would vacate pods from a certain node, this exchange continues and adjusts the sync to the newly created pod. Let's get into the script. At first, I check if some environment variables exist. The key path and the instance is something I need in order to not only exchange keys but also to know how many syncs there have to be. These variables are set in the deployment, which we will get to. Once they exist, I generate the key and save it in the home of the root user under the .ssh folder in a file called id RSA. Next, I use that cat function to output the public key of the pod to the key path folder into a file called key. I also put the hostname into a file in the temp folder called hostname. That step was required as I was trying to separate number and hostname from each other, and that was the only way I could get that step to work. I need the number in the later part of the script to figure out if the key was already exchanged or not. Next, I go through a verification. If the hostname matches the combination of the name and the number, I know I don't have to exchange the keys as I'm hitting the same pod. Example: if the host name is Dovecot-1 and the name and the number of the pod we are in at the moment is also Dovecot-1, I know I don't need to exchange the key as I'm not synchronizing data with itself. If the names are different, I ping the next pod in the cluster until I get a positive result. As soon as I get that result, I move on. At that point, I'm identifying how often I have to exchange the key. The variable num_loops at the end will contain a number of key files in that exchange directory. I am listing all the files that contain the word key and then count them. I need to run through the loop as many times as I find files minus one time. If I find 3 files, I need to exchange keys with 2 other pods. If that number is greater than 0, I run the loop num_loops time. Next, I verify that if I'm trying to exchange the key with a different pod and not the one I'm currently in, so Dovecot 0 with Dovecot 1 for example, I append the key to the authorized keys in the root's home folder. If I hit the same pod, for example Dovecot 1 with Dovecot 1, I continue without executing the exchange. Last step in this part is to create a file in the key path folder with a number of the pod I just processed. Let's say you have 3 pods that you want to synchronize with. By creating 3 files with their numbers 0, 1, and 2, I make sure that I have a verification process in place that allows me to see how many files I have already processed. Only if all 3 are in the folder, I know all keys have been exchanged. Next, I delete the hostname from the temp folder. The last until loop takes care of deleting the key files that have already been exchanged from the combined storage. That allows to remove remnants from the exchange folder to stay safe. Lastly, I remove all files from that key path folder and make sure nothing is left that could lead to a compromised folder or where data could be injected. That concludes the Keyexchange script. As I said, the script will require some updates and might need to be run continuously to exchange keys with other pods, so updated pods can join and the stateful set can be scaled. That, however, will require some time and thinking, which I will push to another day. With that, we can write and quit this file and review the last file. I am copying into the container the ownership.sh script. The file contains an endless loop which every 30 seconds sets the owner of the folder mail to vmail. This file is my workaround if I'm not able to synchronize emails from one container to the other as the vmail user. As you can see, super simple but unfortunately necessary to get the master-to-master synchronization working. With a bit more time and effort, I am sure I can come up with a way to skip this file and get the synchronization working through the vmail user. With that, I am done with the container build, and we will close this chapter. Let's now build this container and push it to my repository. The link is in the video description. The error message you see on the screen is the attempt to restart the SSH daemon, as that daemon will be started upon startup of the container. It's already running, that's why you get an error message. Once the container starts up in our Kubernetes cluster later on, we will get that SSH daemon restarted successfully. Let me now switch over to my Keyexchange master and we'll take a look at the config maps we need for lsync. Let me start off with the Lua configuration for lsync. I have two parts to this file. Before we start, let's switch into our Keyexchange setup folder. And the first file we're going to look at is lsyncd lua base.yaml. As the name indicates, this base file contains the head of the Lua configuration. Of course, at first you have the config map defaults for Kubernetes with a name and the namespace. I then define the settings where to save the status file, the interval, and other settings and options. You can easily expand this part if you need. Then we get into the complicated part with the lsync lua config.yaml. Before we do, we're going to write and quit vim lsyncd lua config.yaml. As you can see, this config map is a script. As I wanted to be as flexible as possible, I had to dynamically build this file, which is what the script is doing. Mounted into the init container, which we will see when we walk through the deployment in the next video. This script collects data such as the name of the pod, the number, and compares these entries again to make sure to not create a sync with itself. Once that is done, the remaining Lua file is built. We start with the sync entry. The sync happens through rsync SSH. We define the source and the host to sync to. We specify its target directory and the delay. We call the rsync service to provide a few options such as verbose sync and in place true for replacing an existing file that was modified. We then provide the details on how to sync, which is through SSH, and add a few options to this portion as well. We define where to find the keys. You remember I exchanged the keys during the startup of the container, and here is where we need these keys. Authorized containers of pods can access each other and don't need a password. I turned off strict checking and sync
with no compression. As this information is collected and added to a string, I run through this command again and append the completed string to the base Lua file discussed earlier. You also might ask yourself, why do you have all the @lb entries in that file? I was not able to get the file built without these entries. At the end, I am replacing the entries with a line break, which you can see at the end of that script. That was my only way to get this file built and accepted by the lsync daemon. As this file is complete, we're gonna write and quit and going to take a look at the last file, the persistent volume claim for the Keyexchange. pvc.yaml. Gonna bring in the claim. To exchange the keys, I need a central storage that is shared between the different lsync pods. This file, or rather the persistent volume claim, takes care of that exchange. Attached to all the lsync pods, the storage is my Keyexchange folder, which you have seen in some of my scripts. The file creates a persistent volume on my NFS storage server with the options read-write once and 100 megabytes. That super small storage is all I need, as I am not persistently writing files. The ones I'm writing to the Keyexchange are deleted again after they are exchanged. With this last file complete, we can write and quit. We have all the files we need for the synchronization of mails from one pod to the two remaining. That video was not too complicated and not too long. However, this Sidecar container, which we discussed here, helps to create a master-to-master sync for a Dovecot deployment with 3 replicas. You can scale this deployment, or rather stateful set, but unfortunately there currently is no way to do that while the application is running. You have to remove the stateful set, reset some of the values, and restart the whole thing. I will describe this detail when we walk through the stateful set and bring everything together in the next video. So, in summary, I walked through the synchronization setup for my Dovecot stateful set and showed how that container works. We walked through the Keyexchange, which is the basis for the synchronization of data between different pods and allows the creation of a master-to-master architecture. However, please keep in mind that this master-to-master only works with smaller files. Large files might require a different setup. What is left to do? I still have some work to do to make this sync a bit more flexible so you can scale up or down the complete Dovecot deployment. I started thinking about how to do that, but I need to further explore that option. I am working on a flow diagram that will highlight what happens and what needs to be done during the changes and what files have to be modified. Once I work that out, I will create a new video and highlight these changes on the container as well as the deployment. What is next? In the next video, I'm walking through the stateful set and highlight how I bring these two deployments together. I will walk through the Dovecot container, the Sidecar lsyncd, which we discussed here, as well as the storage components that we need for this deployment. I will then walk through the stateful set and finish this part of the video series. Until then, thanks so much for watching. I will see you in the next video.